In this video, we're going to talk about density, and this is another way to think about dimensional analysis problems. So this is going to give us a way to work some dimensional analysis problems as well. Okay, um, density uh, is one of those weird things that, for some reason, Gen Chem 1 students seem to have an issue with. So I kind of want to make sure that we get what we're talking about. Okay. Um, Density, and I'll write some of this out in a minute, is the ratio of something's mass to its volume, right? How compact is that thing? Okay. And right, so one of the things is, I have some examples here, right? The oil that he's pouring in there floats over the water because the oil is less dense than the water. The same thing down here. The cork floats on top, the wood floats, but a little bit less, and the metal, that must be a really light metal because it didn't sink all the way to the bottom. But you get what I'm saying, right? Density is why that layers the way it does. Okay. All right. So let's dive into this. Density is, I don't know why that's not going. Okay. Density is an intensive property. So remember way back we talked about intensive and extensive properties. Density is intensive, which means it is independent of the amount. Okay. Um, So no matter how much of a sample you have, the density is always the same, which makes it a good way to characterize stuff. So in the lab, we'll probably figure out the density of some things and use density as a way to determine the identity of an unknown, because it's a great way to be able to do that. Um, so density is intensive because we're taking the ratio of something's mass to something's volume. Okay. You need to know this, okay, that density is mass over volume, but at the same time, I don't want you to be using density as an equation unless you absolutely have to, okay? Which is why I'm doing density the way I do, okay? We're going to see density as two main types of density problems. One of those is density is going to be the answer. We'll see one of these in a second. If density is the answer, then you're going to have three steps to this. You're going to find mass. Sometimes mass is given in the problem. Sometimes you have to do some calculations to figure out mass, but you figure out what the mass is. Find the volume. Gosh dang. Find the volume. Okay. And again, the volume could be given. You might have to calculate what the volume is somehow. Somehow you got to find the volume. And then the third thing you're going to have to do is say that the density is the mass divided by the volume. This is pretty much the only time that I would use density as an equation. Okay. Find the mass, find the volume, and do that. Okay. I'm going to caution you, if you use density as an equation and you do it wrong, you're not going to get any points for it. Okay. Just because you think, oh, it's an equation, I can do the algebra. For some reason, with density, people get the algebra screwed up. And I'm not entirely sure why. I don't want to stress about it. Just don't use density as an equation. Okay. The only time you need to is in this scenario where you're going to figure out the mass, figure out the volume, and then do mass divided by volume. Okay. The other kind of density problem we're going to see is density is given in the problem. When density is given in the problem, you have to use dimensional analysis. Okay. This is why I lump density in with dimensional analysis, because it's a great way to make sure that we can reinforce getting dimensional analysis skills. Okay. So this is going to give us more practice for dimensional analysis as we do stuff. All right. So let's dive in and work a bunch of examples. Here's one. Okay. We have a cube of pure tungsten. We know the cube has an edge length of 2.50 centimeters, 2.500 centimeters, and we know it has a mass of 300.78 grams. Okay, so here's our data. Here's our cube. Okay, so what is the density of tungsten? So this is where we can use an equation. Density equals mass over volume. We got to find the mass. Okay, this was given. We got to find the volume. Volume, we have edge. Okay, that's not quite volume, but we can figure it out. Okay, so first part of this, let's figure out the volume. Volume equals length times width times height. Here we have a cube, so the length, width, and height are all the same. So we can just say the volume is equal to the edge cubed. And we know our edge is 2.500 centimeters. And we're going to cube that. Okay. So whenever you're doing something like this, you're going to cube the number and you're going to cube the unit. Okay. So 2.500 cubed is 15.625. Okay, the units here now become centimeters cubed. So what we've done is we've taken a length unit and turned it into a volume unit. So now we have the volume ready to go. We were given the mass, we've just found the volume, so we can get the density. Our density equals mass over volume. The mass we were given was 300.78 grams. The volume we just figured out is 15.625 centimeters cubed. So we're going to divide this. Notice none of these units are going to cancel out because density should have a mass unit and a volume with it unit with it together. So we're going to have grams over centimeters cubed. Okay, oh, I got to math this out. 300.78 divided by that answer we just had is 19.24992. This has units of grams over centimeters cubed. Okay, we got to worry about significant figures. All we've done is multiply and divide. So this, I'm gonna think through it here. The volume should have 4 significant figures. Our our mass has 5, so this needs to have 4. Okay, which means our answer here should round to 19.25 grams over centimeters cubed. And there's our answer. Okay, that's kind of the straightforward way. We'll look at some of the other type of density problems now. Okay, here we go. Diesel fuel has a density of 0.8375 grams per milliliter. What is the mass of 29.5 gallons of diesel? I'm sorry, that was horrible. Okay, I've given us here that 1 liter is 3.785 gallons, but all the metric prefixes and stuff, we have to know that. All right. Let's see what we're going to do. We have to use dimensional analysis to do this. So our best way through this is going to be dimensional analysis. So we have to figure out what we're doing. Okay. If we look in the problem, we need to start. We have to have a start place. We have 2 things. We have density and we have volume. We have gallons. Okay. Oh, I just had a brain pause. Okay. This is going to be our start. And why did I choose this one? This is the piece of data that we're given that only has 1 unit with it. If we start our problem with the density, then we run the risk of having that density upside down about half the time, depending on what we're looking for. Okay, so if you start with something with 1 unit, you'll end up hopefully on the right track. All right, so our plan then is we're going to take gallons. We know we can get gallons to liters using this conversion factor. Our density has milliliters, so we're going to have to get this liters to be milliliters, and we know we can do that too. And then our milliliters we can turn into grams using the density. Okay, so this is the one that was given. This is our metric prefix that 1 liter is 1,000 milliliters. And then this is the density that we were given. Okay. All right, let's put this to use. Okay, gallons, 29.5 gallons. Okay, gallons to liters we were given. We want gallons to cancel, so gallons going to go on the bottom, liters on the top. The number goes with the gallons, so that's 3.785. Gallons is 1 liter. Okay, then we want liters to cancel and give us milliliters, so we'll set it up like that. 1 liter is 1,000 milliliters. Cool, cool. And then the next thing is milliliters to grams. All right, let's pause right here. You don't have to pause the video. I'm just going to pause the problem. When we're given the density, we were given the density written sideways, right? It says 8. 0.8375 grams slash milliliters. So what that means is we have two options for this. It could be not 8 point, 0.8375 grams over 1 milliliter, or it could be the other way around and say 1 milliliter over 0.837, I forgot the 7.75 grams. Okay, both of those will get the job done. Okay, it's written this way in the problem because it's easiest to type grams slash milliliters. Okay, when you see units like this, and there's several in chemistry that we'll see like this, when you see units like that, the number is always with the first unit and it's over one of the other unit. So here we have 0.8375 grams over 1 milliliter. And the reverse of that is 1 milliliter over that many grams. So the number always goes with the grams in terms of density. Okay. Now, if we look back at our problem, we have 1,000 milliliters on top and we want grams for our answer. So the milliliters has to cancel and the grams has to go on the top. We know the number goes with the grams, so this is 0.8375 grams for 1 milliliter. Okay, grams is a unit of mass, so I'm going to say we're done. Okay, it wasn't asked for kilograms or megagrams or micrograms or milligrams or whatever, so we'll just leave it at grams. If you're given a specific unit, go to the specific unit, but here grams is fine. All right, gallons cancel, liters cancel, milliliters cancel. We're left with grams. That's beautiful. Now we're going to math it out. Okay, so do what I always do. 29.5 times 1,000 times 0.8375 is 24706.25 divided by 3.785. Okay, this has units of grams because everything else is canceled out. Then we're going to divide those two things. That number divided by 3.785 is 6, damn it, sorry, 6527.41083223 grams. All right, now we have to worry about significant figures. Purple, why not? Okay, this is 3 significant figures. This is 4 significant figures. This one is exact. Because it's a metric prefix. This is a given one that's measured. This is density. Density is measured. So this is 4 significant figures. So we have 4 exact, 4 and 3. So this needs 3 significant figures, which means that is our answer there. Okay. So when we round this, 650, that 7 is bigger than 5. So that's 3. Now it's not just 653 because we still have this place here. It has to be 6,000. So we have to have a placeholder 0. And that 0, remember now, is not significant. Okay, we're going to give it units of grams. Blah. There's our answer. Okay. Not too terrible. I think I have one more on here. Yes. Okay. Quick Google search says that the density of ethanol is 789 kilograms per cubic meter. What is the density of ethanol in units of pounds per gallon? All right. We're converting 2 units at the same time. This is what I'm giving us. Here's our same gallons to liters conversion. And now we have pounds and grams because we have to get to these English units. All right. This is a problem that you could work multiple ways. Okay. Let's write out this number. The only number we're given is 789 kilograms per cubic meter. What this means is we have 789 kilograms for 1 meter cubed. Okay. So our goal is this kilograms, we got to turn it into pounds. And this meters cubed, we're going to turn it into gallons so that we get pounds per gallon. Okay. You can do this as 2 steps where you take the kilograms and convert it to pounds, take the meters cubed and convert it to gallons, and then take the pounds divided by the gallons. That completely works. Okay. You can also do both at the same time. Okay. I'm going to show you both at the same time. I might even have time to do them individually on the next slide if I have space. Okay. But I'm going to start with them both at the same time because both at the same time is how I would work this. Okay. So we already know where we're going to start. We're going to take our kilograms and our meters cubed and we're going to convert. Okay. So this is our plan. Okay. 789 kilograms, 1 meter cubed. All right. Now we got to get kilograms to be pounds. We're given grams and pounds, so we can get our kilograms to be grams. That's our metric prefix. All right. So kilograms need to cancel, grams on the top. All right. 1 kilogram is 1,000 grams. Okay. Then this conversion factor we were given is grams per pound. We want to get grams on the bottom so the grams cancel out. Okay. Here we're saying it's 453.6 grams is 1 pound. Cool. Now for this, now we're at pounds. Okay, that's good. We have pounds. The next piece, we want gallons. So we're gonna take our meters cubed and turn it into gallons. Now remember, dimensional analysis is going to tell us how to do it. Okay. Meters cubed to gallons is going to be weird, but we can think about this as, remember, meters, we can get to centimeters, right? So if we have meters cubed, we can get to centimeters cubed. If we have centimeters cubed, we can get to milliliters. And if we have milliliters, we can get to liters. And if we have liters, we can get to gallons. So this is going to be a few more steps, but we can do it. Okay. We need meters cubed on the top so it cancels out. And we need centimeters cubed on the bottom. Okay. Remember, our conversion factor is for 1 meter, we're going to have 100 centimeters, which means that we're going to take this and we're going to cube it. Okay. Then our meters cubed is gone. We have centimeters cubed. 1 centimeter cubed, we need the centimeters to cancel, is 1 milliliter. Okay. We're going milliliters to liters. So we want milliliters to cancel, so it goes up here. There's liters. 1 liter is 1,000 milliliters. And then we're going to take liters to gallons. So we want liters on top and gallons on the bottom. And we know 1 liter is 3.785 gallons. And then we should be done. Okay. Let's make sure everything cancels. Kilograms, kilograms, grams, grams. We have pounds. Good. Now the other side of this, meters cubed, centimeters cubed, centimeter cubed, milliliter, milliliter, liters, liters, and we have gallons. So we have pounds on top and we have gallons on the bottom, which is what we're looking for. So now we're just going to math this out. Okay. 789 times 1,000. 1 times 1,000 again. Ooh, this is a lot of numbers here. All right. Okay. This is 789,000,000. Yep. Okay. And that is pounds. Okay. And we're getting meters cubed to gallons now. So we're going to do the bottom. Well, that's not really pounds. Let me erase that. Okay. Then we have 1 times 453.6 times 100 times 100 times 100, right? Because we cube this, so we have to times it 3 times. Times 1 times 1 times 3.785 is 171687600. This fraction has units of pound. Sorry. I don't know what happened. I bumped something weird. Okay. Units of pounds per gallon. All right. Now we divide those two things. That number divided by that number is 0.459556115. I ran out of room. pounds per gallon. Okay. Last thing we got to do is significant figures. So let's say this is 3, this is exact, this is 4, this is exact, that's exact, that's exact, and this is 4. So 4, 4, and 3. So this needs 3 significant figures. There's our 3 significant figures. All right. So when we round this dude, yeah, okay. We round this dude. Okay, this is a 5, so this 9 becomes a 10, so that's a 0, so this becomes a 1, which makes that 6. So 0.460 pounds per gallon. I'm sorry I got small there, okay? And I know I have another slide, so I can use that as a way. I'm going to do it again, the two-step way, okay? This does both at the same time, okay? You just want to make sure things cancel. That kind of, the setting it up part kind of can confuse people. So if you want to do it in 2 steps, let me show you that way. All right, the same idea. We're going to get 789 kilograms per cubic meter, and we're going to turn it into pounds per gallon. So what we're going to do here is we're going to do it in 2 steps. Okay, our first step is we're going to take, our kilograms and get it to be pounds. Okay, and what do we have? We have 789 kilograms. Okay, we know 1 kilogram is 1,000 grams. And we want grams to cancel, and we want pounds for our answer. 1 pound is 453.6 grams. Okay. This is 789 times 1,000 divided by 453.6. So this is 1739.41799 pounds. Okay. This number has 3 significant figures. So what I'm going to do is I'm going to mark this because that means it has 3 significant figures. We'll leave that later. The second thing we're going to do is we're going to take our cubic meters and convert it into gallons. Okay. Now you're going to think, oh, we don't have a number to go with the cubic meters, but we do. Remember, it's 789 kilograms for 1 cubic meter. So this is going to be 1 meter cubed. Okay. Remember, we can take meters to centimeters because there's 100 centimeters for 1 meter, and we're going to cube that. Okay. Then we know that not meters, centimeter cubed is 1 milliliter. And we know that 1,000 milliliters on the bottom because it has to cancel, is a liter. And we know that 1 liter is 3.785 gallons because we were given that. Okay. All right, so we're going to take 1 times 100 times 100 times 100. 1, okay, this is a divide, then we're going to multiply by 3.785, and I'm going to divide by 1,000. It's the only number on the bottom we can do that. And this gives us 3,785 gallons. And this has 4 significant figures because everything else in this is exact. So there we go. Okay. Now, the last thing we're going to do is we want to get the density. And so we're going to say, to get the density, we want pounds over gallons. So our pounds, 1739.41799 gallons divided by 378. I wrote the wrong unit. That's pounds. 3785 gallons. Now that's pounds per gallon. And if we divide those two things, this number divided by that number, we get 0.459556115. And this is pounds per gallon. Okay, we said the top number had 3 significant figures, the bottom number has 4 significant figures, so we round this to 3 significant figures, which is 0.460 pounds per gallon. And see, we get the same number that we got before. Okay, if you have questions, let me know. We'll work a bunch of these together to remember, practice makes perfect. You can do this.